So we have to come up with our own fill algorithm. So we're going to divide our quadrilateral up into two triangles. Let's say this is our triangle. We find y top and y bottom. That gives us y mid. That lets us subdivide this triangle up again like so. Then we do a for loop from y top to y mid, where our x start bound is the equation of this left line, and the right, the equation of this right line, right? Then once we reach y mid, we change our bounds so that way the equation on the left is now this line, the equation on the right is this line. Hopefully that'll work, and I didn't foresee any other problems with this. So what math.max of all the different y's, y1, y2, y3, and that's our max y. But we don't know which one that is. Okay, new plan. And there, now we have the y's sorted in order because we used the sort function. Yeah, okay, we're just going to change this to points. And we're going to put them together so that way we have them connected to each other and we know where the points are. Great. But now we can't just do a minus b. We have to do a1 minus b1. Right, so it works, but I need to have it as the right name. So now we have to find the equation of the left line and the right line. First off, let's find the slope. And I think because we're doing x position, we're going to do run over rise, I think. So that way we can get it in terms of x. So that's the run, and we're dividing by the rise. Okay, we want to do this for all the different points. So we don't say, yeah, we just have to change this to 1. So this is I plus 1, and then this is I plus 1, but then we have to mod it by 3, I think. So mod by 3. Right, so that way when we get to the last point, it'll do the next point. And that gets us all the different slopes in terms of the x direction. Okay, so we started our top y, and we go all the way down to our bottom y, and then we have to know our x start. Oh, right, okay, we don't go all the way down. We go from the first point to the second point. We start at 1, 0 plus I multiplied by the slope of our 0th line. And then we end it right at our x point on the 0th point multiplied by our slopes, but not our 0th one, but our second one. For the other one, the other line is the same, but we use a different slope now and a different point on it. Hold on, I'm going to change these fors to if statements. Okay, right, so we go from 0 to the bottom, but our I, which is our current y, if it's greater than 0.11, we do one thing, else we do the other thing. But our x end, I think, theoretically is the same thing each time, so we don't need that in there. We probably want to declare our x dot out of here. And now that we have our start and end position, we can create a j, right, which goes until our x end, and that's like that. That's when we do set pixel of our j is our x, I is our y. Let's just fill it in with gray like that. Let's see what happens. Broke it in a for loop context. Okay, how did I break it? Oh. Okay, I see why it's failing. We're going from start to end, but the start isn't necessarily the smaller one and the end isn't necessarily the larger one. Alright, so you know what? I'm just gonna call them x1 and x2. I'll just change it to x1 and x2, and we determine x start and x end through a min and max function. Also, these need to be parsed as integers because we can only have whole numbers. So we're using var x1 here. That's not good because that's our parameters, and so we probably shouldn't reuse those. So let's change them to px1. Also, I'm declaring the variable within the loop here, which is not good. We should just be using what it is. So we're just changing that to px1. Down here, this is px2. Put those in here like so. Also, I'm doing this in the wrong order. I'm saying greater than 0.11. Well, actually, it should be less than here because then it's above that point. Also, our I value is currently going to start at 40 when it should be starting at 0 because it's the initial point. So we're going to make a value called t value, and then we're going to subtract the initial amount from it, and then replace I with that, so that way we have the right amount of change in there. Also, we're going to make it less than or equal to, so that way it's inclusive in the points that we're including. Okay, so here's a shape we can try and render, and I'm just doing this right now so I can test to make sure that my rendering is working. Right, and so we wind up with this. So it's close. It almost looks like we want. It's not quite there yet. I don't know what this gray bar at the bottom is doing and why it's like that, so I have to figure out what's the deal with that. So I went and isolated it down to just one of these triangles. Right, I'm just drawing the second triangle in this case. And I think I chose the wrong slope for one of these, so that's the problem. So let me just try different slopes and see what happens. Nope, that's not the right slope. That's not the right slope. That's not the right slope. Maybe it's this one. Nope. No. Okay, I figured out the problem. T-val is different for the top and bottom half. Yeah, there we go, it's fixed. Check it for both of them, and okay. What could be causing that? Problem is that T-val is being declared after I'm using it, which is not what you want. So let's reverse that order. And there, it's fixed. And we're drawing this shape properly. I also want the test to see if flat lines are rendered correctly, because I think we're dividing by 0 in this case, but it seems like they're working fine, so I don't know. The other thing I want to do is I want to set bounds at the screen edge. So in the math.max, well, the lowest max value should be 0, because we shouldn't go any lower than that. So if px1 and px2 are both below 0, then we use 0. And here, the minimum value, if px1 and px2 are both above that, then we want to use the client width of the canvas. So what is it? Canvas.client width. But we also want to do that for our y values. So I think for that, what we probably want to do is we want to have a y start and y end. And here our y start value is the point that has the y value that's closest to the top of the screen. The end is the closest to the bottom. But we want to do the same thing as before. Right, we min-max it with the canvas's client height and 0. Let's draw a point off screen. How is it wrapping? You know, my guess as to why this is happening actually is that's actually each one of those points is one higher than they are on the left side. And since everything is stored in an array, we're just like indexing it out of bounds. Okay, so it looks like we're pulling up -40 for our value here, so that's why that's ending up the way that it is. So I did this min-maxing wrong. So we start at whatever is smaller between the two of them, but that starting value needs to be greater than 0. And same here, math.min, canvas.client width. Right, we do it like that. Now I don't know if our y's are correct. It should be max here, 0 here. It should be canvas.client height and this should be a min. Let me uncomment out the line. Okay, it's still broke. Okay, so this is our square before. Well, it turns out actually that this was broken anyway, apparently. We have to get our x starting point to be the correct value. It's reusing the point. So we need to remember our progress. Yeah, you know what, let's just make 2 t-vals. Okay, that looks right. Did I actually fix it though? Okay, that looks like a polygon. That looks like it's functional. Alright, now it's time to see if this actually functions with what we have. We're going to turn render quads back on and see how slow it goes. Oh boy. Please function. You know what? Oh, you know what I think the problem is? I bet our j's and i's are not even values. Or it doesn't know how to set a decimal value. So it is the fact that I didn't use parseInt on it. Okay. Yeah, okay. So we got to parseInt this. Am I even using y_start and y_end? No, I'm not. I think I just forgot. Yeah, I didn't even use y_start and y_end. Fantastic. Okay, we're drawing something. Good. There's some weirdness going on when the slope gets like really, yeah, look at that. Like what's going on there? That's weird. Okay, but see, okay, at the bottom it sometimes screws up. So there's, whoa, what is happening there? Yeah, this side. Okay, I see what's happening. It's a little bit more obvious when there's just one triangle on the screen. Okay, I mean, yeah, so we're splitting the triangle into 2, and when one of the triangles shrinks to its smallest size, it blows up infinitely. Why is our t-val so large? What's our slopes 0 here? That's very large. That's a very large slope value. The t-val should be 0, and it's not. So I think t-val should be parsed as an integer, and that might fix our problem. Alright, there it is. And when it shrinks, it doesn't act all weird. That's cool. Draw both of the triangles. There. Okay, cool. That looks correct. Okay, now let's draw the whole prism. Okay, it's already starting to lag. It's continuing to lag, but at least it's running, kind of. 2 pillars is pretty laggy. You can hear my computer getting louder because it's struggling to run this. Oh boy. And then if we try to draw all 8 pillars, oh boy. Now it's really lagging. This will not do at all. Let's get the call.r, the call.g, the call.b. That way it's the appropriate colors of what it should be. Yep. Oh boy, it's even slower now. Okay, this is still just so slow. All right, we're gonna just 1 pillar, okay? Just 1. This is not functional. Why should I even bother continuing with this? Okay, minor improvement. Let's not do hex to RGB every single time. Let's not do that in the for loop because it's not changing. Well, apparently, trying to run a 3D engine entirely on CPU may not be the best of ideas. And unfortunately, it doesn't seem like JavaScript can naturally access GPU.